Welcome back, everybody, pre-calcsters, if you will. Today, we're going to continue in 4.8, and yesterday, my notes didn't save, but I can get back to where we were. We graphed arcsine of x. So I'm just going to catch up. You guys already have this in your notes. We graphed y equals the arcsine of x. And when we graphed this, I think we changed it, right? Instead of saying y as a function of x, we did it as x as a function of y last time. Okay, so when we did this table, it's just backward, right? We pick the x and then we plug in the y. Now, we've constructed the table. Did we do it entirely yesterday? Did we get enough points to draw the graph? Do we have to do it? Do I need to copy the whole table again? Now, for that, we used this if and only if statement, the definition of the inverse sine, to wind up with x is equal to the sine of y, and then we just plugged them in, right? Now, as we go back through this, we can, and some of you I imagine are uncomfortable doing x as a function of y. It is the exact opposite of what we normally do. That's a natural thing to not love doing. If we want to do it the other way, and I just want to make sure we can talk about it and see how it works, when we plug something in to sine and regular sine, remind me real quick, and I'm going to do it in pink, so it's up to you if you want to write it. What goes in here? If I'm taking the sine of something, what do I put in there? Like if I said, what's the sine of 3? That feels like a weird question to me. Why? Talk with your neighbors. I'm going to ask about this one next. And we have this statement yesterday in our notes. Talk with your neighbors about 60 seconds. What goes into the argument of each of these is really what I'm focusing on.
I'm kind of lost.
I heard you. So, what was the first thing you said?
Yeah, X and Y.
So you're not wrong.
Why?
Not the answer I'm looking for, but you're not wrong. If I said take the sine of 6, you just that feel weird. You
the domain.
Oh, so just flip?
maybe not
The
super,
domain of sine.
but it should feel kind of wrong. If we look at anything,
That's the thing kind of the case.
and we'll just go like all right, I'll just get sine. What?
It's
What
got
is
big pi.
so 0 and if I have pi, and we're just gonna bring So where did these come in from? We've been using x, but good. And why are the what's? Good. Great measure. What we're looking at. Okay, check it out. This question might seem kind of weird. If we're looking for the sine of something, I think the sine of 2 feels like a weird thing to say. Now, we've done a problem where we had like the sine of 2 or the sine of 4. It was on our quiz. But if we look at any sine that we did, normally we plug an angle in here. Do you guys agree with that?
Mm-hmm.
We plug an angle into the sine function, and we get the ratio. That's what this thing gives me. What if I'm plugging into arcsine? Instead of plugging in an angle and getting a side, what swaps if we do a function's inverse? We plug in a side length or a value of sine, and we get the angle out of it, right? Now, if you're comfortable with those two swapping back and forth, and I'll just make sure we have this, the statement that I was referring to from yesterday or the day before was SOHCAHTOA, sine, cosine, tangent, use if we have an angle to plug in, and we use arcsine if we have a side to plug in. And that should be in your notes. I'm just going to refine and make sure that that's listed again. This is an angle right here, if we're taking the sine. This is a ratio of sides, and I'm just going to call it side stuff here. Now, when we built the graph yesterday, we can switch it, and we can do our function backward, and it gets a little weird. And we get the right answer and everything, but I want to think about it with this in mind. I'm going to cross this table. Don't cross yours. I just don't want to get it confused. What if we don't switch it, and we just make it so it's a regular function that says, instead of y and x, we did a yx table yesterday, right? So I don't know why I undid it. Anybody notice that I had it written backward? Because you have y comma x yesterday, correct? On your table? Okay. So then I'm going to use this table, but I'm going to give it a third column here. So if we're looking at it, we don't want to have to make this weird little switch. I can work backward all the same. We'll get the exact same graph, but I just want to make sure that we're comfortable if we didn't like it here with switching it to yx table, which is wonky, we can do it here. Are there any nice sine values that show up between negative pi halves and pi? Like really convenient values. And you may have to check your unit circle if you don't have it memorized. Follow up. I would love a 10-minute unit circle quiz on Monday. Cool. Pi's 6, so careful. Let's I don't disagree, pi 6 is really nice. But what do we plug in if we're doing arcsine? The side, right? So if you give me pi 6 Matilda, it's certainly what I would plug in for this one, but I wouldn't plug it into the arcsine. So if we're looking at this, I'm just going to start. And I think if we're looking at the right half of the circle, because that's where we restrict our domain, I think that -1 is a really convenient place to start. Which angle, and I'm going to write this, instead of writing arcsine of x, and I will write arcsine of -1, this is going to be the only time you'll ever see me write wordy sentences inside of a table ever. When we do this, just like when we did logs, remember, the question that we're asking is which angle makes the sine equal to what is it going to spit out at us? So careful, you're close. But we're looking at which angle makes a sine. What is the length of the side that we just plugged in? -1. So what angle does that, Dolan? Because you had it. -pi12. If you look at our table from yesterday, did we have -pi12 for y and -1 for x? And we get the exact same values, but now we don't have to do this wonky switched around thing. If I wanted to do this, there's another nice side length known as 1/2. Where does -1/2 rather? What angle on your unit circle gives me a sine value of -1/2? Pi 6, -pi 6. -pi 6. And we can construct the exact same table from yesterday without switching it. Now, I prefer to do it this way with x's and y's plugging into the arcsine. But if you're not comfortable plugging into the arcsine, just make sure that we're comfortable saying, like, look, we have an alternative that we can use. Okay, so we're going to take a short transitional piece because it's a natural, like halfway through the section. We're going to work for 15 minutes on stuff. Now, you will not finish all these problems in 15 minutes, just a heads up. We'll go 15 minutes. We'll come back in and we'll briefly talk about some of the other ones. But if you're okay with sine and arcsine, making the transition to cosine and arccosine and all the other inverse stuff, pretty straightforward. This one time is we have to do it, and it's kind of wonky and weird. We'll make sense of all the other ones today also, though. So for the time being, I'll put this up on Google Classroom here in a second, but I want you guys to start homework 4.7, which you will find waiting for you on page 326. And I'm combining a couple of homeworks here. And let's see here. We're going to knock out problems right now, and I'm going to add some, and they might fill in the gaps, but that's okay, I hope. I want 1 and 5 and 6 and 12 and 16 and 17. You might finish these in the next 15 minutes. If it doesn't take 15, we'll adjust. I'm not trying to burn you, but I want to give us more time to work on stuff if we need more time. But if we don't need it all, we're cool with it. Okay, we're going to say 15. We'll go 10 and then 5 because I don't know how to set this yet. I never learned. Okay, 10 minutes we'll start with, and then we'll pick back up, and we'll jump into the second part of the lesson. Addison, I almost wore the same dress today. All right, so we talked about inverse sine stuff. What else do you think we have to talk about? Cosine. And let's just jump in. So the last part, and we may finish today. We'll see how it goes. We're still in 4.7, same section, and we are looking at other inverse trig functions. Do you want a definition before we jump in? Okay, I've not looked at the word of the day today, so I have no idea what it's going to be. Other inverse trig functions. Oh, I knew yesterday's for the first time, and I was pretty proud of it. Okay, don't shout out what it means. And that was only to do. We're going to start by talking about the arccosine. Ooh, and I have all of a sudden a brain hiccup because I don't know if there's two C's in this word. I assume there are two. Okay, arccosine. Yep, couldn't tell. It feels odd. The arccosine. Now, as we're looking at this, you could write it like this. What do you think might be a better way to write this? I'll even write it here. Can I use a negative exponent here for a second? Now, I don't really care if we say theta or x or y. It doesn't matter what we call it. Whether it's arc cos or the inverse cosine, we say it the same way. Now, I don't know why I wrote the f of x. I was going to write it down here, but we'll try to make use of it. What I want you guys to do, and this is going to be like a 30-second thing, I want you to sketch really roughly, without making a table, 2 periods of cosine. One on the right, one on the left. Okay, now this next question you do not have to write down. I should have done it in pink. But once you have it graphed, what I want you to talk about with your neighbor, one, verify that you guys agree on the graph. But the same question we looked at yesterday. Where should we restrict the domain to ensure one-to-one or injective? Okay, graph cosine, and I just want to know where is our restriction that we have to deal with. I'm going to give you guys like a minute or so to talk it out with your neighbors. As long as they start up top, I'm cool with it. What's the period of cosine?
2 pi.
So I know it goes out to 2 pi. And I'll just put these little tick marks on there that are nice. And I'm going to go out to negative 2 pi since I'm doing 2 periods. Does cosine start at 0 or 1?
1.
1, right? The cosine of 0 is 1. Cool. So I start up here and we'll just get it sketched. And I know it ends up here. So I'll put the half ticks on there as well. That's way too high. I'm going to make it a little smaller. I don't like how high that is. Okay, here's what one period of cosine looks like. And if we want it, here's the second period of cosine. Okay, what I want you guys to do is, that question about the restriction, I want you to lightly write it down. Tell me what you think it is, just before we all shout it out. Where should we restrict this domain? If you're not sure what I'm asking, you're not sure how to answer it, please let me know, because obviously we'll have the answer, but I care way more about, do you understand why? Check it out. For these questions, I wanted to pass a horizontal line test. It's the same thing. Right now, it doesn't. No, because it's touching 3 times, but I know it'll touch it in a minute. So what I'm thinking is there a section to where, is if I go back as a sign, there's one page yesterday. So yep, so when we did this, when we graphed, and you don't have the graph that we used, maybe go on. Okay, so here, where did we restrict it? Like you picked this part, which is fine, and then I just picked the same thing, but I just moved it over. So we just picked one little part where it passed, right? So you're saying 2 pi. Do you mean pi? Okay. So if I look at just that section and only there, I pass the horizontal line test and touch it pretty every time. Is there a place here that I could restrict it so I can have great value?
Okay, guys.
But I only hit it
Apparently, I sound like a bird.
and I want you to highlight that or find it. Okay, what do you guys think? If I want to show every value of cosine, where would I need to be? And I'm going to bold this. I want it to be just a section of this that's injective, which is a fancy way to say it passes what? Horizontal line test. Okay, is it this section? No, right? Like, obviously not. Now, where there's a lot of sections it will work. Where's the nice one? If I start at 0, which I realize I'm at a crest here, I'm going to start working. Here I am. If I stop here, have I hit every value from -1 to 1? Do I pass the horizontal line test? So here's like the same thing that we did. We're going to make this table a little bit nicer than we did the first time, just for organizational sake. We're going to have y equals the cosine of x. And then we'll look at with restriction. And then I want to think about, on the other side of this, its inverse, which we'll say the arc cosine. So x is equal, and I'm going to just change it. We'll just use f of x for this one, just so we don't confuse x's and y's too much. The arc cosine. Okay. So check it out. As we're looking at this cosine, I see that red section. It has been restricted. I now have a function that's 1-to-1. I have injectivity, which means we have inverse to exist as a function. Where did I restrict the domain of this cosine? Or where did you restrict it? And I hope we all did the same thing. From where to where? So I go from 0, I agree with you. And what was the other end? Pi. Does everybody agree that this is pi here? Okay. The second I know where I needed to restrict the domain of cosine to work, what did we just find? We just got the range of the arc cosine for free. It's the same thing. So if we look at these, and it's going to be a little bit backward, only because I have domain and then range here, and they switch places. But as long as you write down, you know what RAN means, the range, we should be okay. If you know the domain, you get the range for free. What is the domain of arc cosine then? And I want you guys to go ahead and jot that down. I'm going to call a random person here in just a moment. What's the domain of arc cosine? Now, I switched sides, right? Like we switched places, but it's okay. I want to see that we can connect these pieces. Like, don't take that as if you're struggling. It doesn't mean that like anything is wrong with the way that you're thinking. It just means we haven't quite hit that eureka moment yet. It's going to happen, hopefully like now, but if it happens Monday, we're still okay. The domain of the arc cosine is a hard thing to think about. The good news is between a function and its inverse, something happens. I'm not doing this for fun. What am I trying to get you guys to tell me happens when I go from a function to its inverse? What swap or switch? X and Y, give me the bigger sets. The bigger collection of all x's, the domain and the range. If I ask for the domain of arc cos, it's no different than if I ask for the range of cosine. Now, this one we've got a lot of practice with. The range, what values does this run between? -1 and 1. And I should have been more specific. I should have said which y values does this function, like what's the range of this function. Now, if I get the range of cosine, I know because I just swap, I get the what for free? The range of cosine is the same as what? The domain. I agree. And we have it. Now, for these, we can graph this all the same. We could set up our table. I'm not crazy focused on the graphs of the inverse trig things right now. Just so you guys know, I want to be able to use these things because we're going to build up to the lovely application stuff. So we're going to give ourselves some nice definitions. If you're dying to graph this, I am happy to graph it with you. Stop in at lunch, stop in after school. We can do as many inverse trig graphs as you are just dying to do. Cool. See all 12 of you, I imagine. Sweet. Okay. So because I'm more concerned with can we use these functions than I am with graphing them, we're going to sneak in, and I just want to see, we started off with arc cosine. Could we do the same thing for all the others? Do you think we need it? Okay, so we'll play it by ear. What I would like to do for now is we're going to give ourselves some definitions. And once we write the first one, and I'm going to use sine again, definitions of, and I'm going to write arc trig for the inverse trig stuff. Now, for each of these, we're going to do a couple things. We're going to write the function that we're looking at. Cool. We're going to write the definition of it. We're going to write the domain of it, the range of it. And then the other thing that I think we should do is once we have the domains locked in, we should really focus on which part of the circle we're using. Like, for example, we haven't talked about it today, not super. What half of the circle should we use if we're thinking about arc sine? The right half. And we know that because we restrict from negative pi halves to pi halves, which is the right half of the circle. So we're going to make a small table here. We have our function and the definition of it. And then our next column, and it's going to move a little bit over, is we'll have the domain of that function, the range of that function, and I do think it's helpful to have part of circle that we would look at. Okay. Now, what I am doing here is pretty close to what I would say if we were using note cards on everything, what I would have on a note card. I do think that we'll have to have this like down pat by the end of the year, or by the end of our trig stuff at least. I'm not super concerned if we have a little bit of this stuff on a note card. I'll provide you guys with any additional resources that you might need. So, jumping in with these, let's start with the one that we looked at yesterday. We're only going to discuss arcsine, arccosine, arctangent, arcsecant, and arccosecant. All of them exist all the same, but we're going to focus on the three nice ones. So let's knock out our first one, and I'll switch colors every time. I want the definition of one that we've already talked about. If I say that y is equal to the arcsine of x, this is true if and only if, and this is just the definition. How did we define this? Now I see people are writing, so I'm going to not count that as my waiting. This is true if and only if something. And here's the cool part. If you don't remember it off the top of your head perfectly, one, your first few, like 5 problems might have been a little bit harder. But 2, you don't have to remember it, because where on earth could you possibly get this answer? In your notes, 1 page back, because we did it yesterday, I think. This is if and only if what? The sine of, I don't think it's the sine x. The sine of y equals x. Now, for this one, just to make sure we're all on the same page, if you need to say domain of inverse, I'm okay with it, because I'm going to be talking about arcsines and stuff here. The domain of our lovely arcsine function is the same as the range of sine. Yesterday, we said it was from -1 to 1. And the range of arcsine is just the restricted domain of the original function. Where did we restrict to? For sine yesterday. -pi/2, 2π/2. And just as a quick reminder, which part of the circle? The right half. Okay. Now, for these, this next one, and we're going to only list all 3 of these, but I'm just going to separate them. I'll switch colors, and there's no rhyme or reason to my colors that I'm picking. I just want to be able to see them differently. Well, we have arcsine. Cool. I want you guys, and I just want to see how this turns out. I'll give you like 2 minutes. I just wrote the exact same thing. Disregard that. I want you to do the same thing and finish every other part of this. I want the definition of arccosine. I want to know what is the domain of arccosine, what's the range of arccosine, and which part of the circle are we looking at? If you happen to be done with this already, because you kind of saw the direction this is going, I give you a challenge. Arctangent's the third one I want you to think about. So if you are all the way through, I'll even leave a little, I'll put a line here. Too big. And I'll pause it, because otherwise it's just going to be like 2 or 3 minutes of silent, awkward stuff for Red. Wake up, Redmond. If you have a hard time thinking about the inverse, which is natural, because we don't deal with these ones near as much, all we have to really have down, like solidly, is what the basic graph of cosine, or if you think about the unit circle, that also works. And then we just have to think about the restrictions that we make. What's this? If I think about cosine instead, how can I switch this between arccosine and cosine? What's the if and only if statement? The cosine of y is equal to x. Okay, so beyond that, if we think about cosine, the range of cosine, what's the smallest cosine ever gets? -1, and the biggest? 1. So the range of cosine becomes the domain of its inverse. It's exactly what happened. Here's the harder part. Based on what we've done, and this graph is why I did it, where did we restrict the domain here? Because that's going to become our range of the inverse. I went from 0 to where? Pi. And we had it written here, and I'm aware of that. I just want to make sure we can see it again. So if the range of cosine is 0 to pi, sorry, the domain of the cosine was 0 to pi, then the range of its inverse is 0 to pi. Okay, what part of the circle are we working on? If I start at 0 and I go to pi, like physically, everybody stick your arms out in the direction of 0. And now, don't just jump right to it, but drag your hands through some amount of angle until you get to pi. And we're here, and we're where? We're waving, and we're waving on which part of the circle? The top half. All right, cool. I'll try to leave the hip hop at home for the future. Well, how do we define arctan? Y is equal to the arctangent of x if and only if what? The tangent of y equals x. Okay, how many of you guys, honestly, without me doing it, remember what the graph of tangent looks like? So I got to think from your perspective. Just that, over and over. And that might not have been a huge help. You do not have to graph it again. Remind me, tangent is sine over cosine or cosine over sine? So it's going to have an asymptote wherever cosine is 0, which happens at 0, and it happens at pi halves and negative pi halves. Okay, so if we think about cosine, or tangent, I know it runs from here to here, and that's supposed to be halves. And it looks like this. And then another period would look exactly like that just over here. And this is what tangent looks like. So if we have the graph in front of us, it's super convenient. Can you tell me the range of this function? How low and how high does it go? All real numbers. What if I wanted that as an interval? From where to where if I'm including every real number? Negative infinity to positive infinity. Okay. Now, this domain is special, and it's way nicer than cosine and sine for this particular problem. If I draw the asymptotes in where they really live on this graph, and they're at every multiple of pi halves, is it already kind of restricted just naturally? Where's it naturally restricted to? Like, I could do 5 pi halves to 7 pi halves if you want. I don't want to use that one. You shouldn't want to use that one. Where's the natural restriction? From negative pi halves to... Oh, so if that's a domain that I need to use, that must be the range. Now, slight difference here. Why am I not using brackets anymore? It has an asymptote, right? It's undefined there. Okay. And here we are. If we're on this lovely interval, on which part of the circle am I working? The right half. And now you could make the argument that you're on the left half as well, and you could try to argue this. And if you do it correctly, you could be right. But I do want to make sure that we can see where this comes from. If I know that I'm going from negative pi halves to pi halves, what I'm thinking is I'm starting at negative pi halves and I'm working around this direction, right? Now why would I start there? I'm trying to do it backward, but whatever. Okay, I start here and I work around in the positive direction. Now, if somebody says it's this half of the circle, you're not wrong. Not entirely, but you're not working from negative pi halves to pi halves if you use the left side of the circle. You would be working from pi halves to 3 pi halves. And we could pick that, but if we get the chance to include 0, we probably should, right? Because 0 makes stuff nice. It's easy if we get 0. We could pick any arbitrary interval of tangent to use because each one is separated just naturally to work and it's 1-to-1 and injective, but we always just pick the nicest. Okay, with these, the biggest reason that I need the domain stuff is because I'm going to try to trick you. Yesterday, I asked you guys to find me the arcsine of root 3. But sine never has, there's no angle that makes sine have a value of root 3. So it was undefined, it didn't exist. We can pick that out by choosing and knowing these domains. Whether you know them off the top of your head or we use them, doesn't matter. We're going to do a couple quick examples. And then I think that we're going to be done with the lesson, which is going to be perfect. So, couple quick ones. And we're going to try to do this. We'll just say evaluate. And it's not red to match tangent for any specific reason. I just didn't change color. So I'm going to keep this table up as much as I can. and we're just going to do a couple of them. So here we go. On A, I want us to find the arc cosine of root 3 over 2. And before you just jump ahead and say, oh yeah, it equals x or y or theta or whatever, just hold off on a second. Let's see if we can't start to get rid of this middle step. When I look at this, I don't like thinking about arc cosine really, not particularly. But I do recognize this number. Do you recognize this number? Where do we all recognize it from? It's a side length, right? If I take the arc cosine of something, it's not going to give me a side length anymore. It's going to give me the what? The angle. So you do not have to write this, but if it will help, this is how I want you to think about these things, and it will help save a ton of time. Which angle, and I'm going to not even write it specific to this, which angle in the domain of cosine, and I guess it is specific on this one, spits out root 3 over 2. Now, this is really informal language, and I want to make sure that because I'm doing it so informally, does that statement make sense to you? Okay, so first thing, if we're in cosine, which part of the circle are we looking at? The top half. Find me anywhere on the top half of the circle an angle that makes a cosine root 3 over 2. You might have it off the top of your head if you're really good at quadrant 1. But if you have to look, it's okay. Monday, you're going to need the unit circle again, though, because we're doing a quiz Monday about the unit circle. Top half of the circle, is there anywhere where cosine is root 3 over 2? 5/3? Is cosine x or y? It's x. And where does it happen? Pi 6. Now, I would encourage, and I want you guys using these questions every time. If anybody's looking going, I don't like that, I don't know what to do, you can get by without doing this, but you are going to be spending a little bit more time than I think you need to. If we want to do it the long way, and I just want to make sure we can do it, and this is probably going to be the only one we do. If you don't like this, and you're not cool with this question, what could I set this equal to for now? X, or theta, or y, or z, or whatever you want to call it. I'm going to call it a beta for fun. Okay, what's my next line read if I use the definition of arc cosine? The cosine of, and I'm going to switch sides just so you know, I'm not expecting you to tell me the arc cosine. Cosine of beta must be equal to what? Now, if we do this, I just want you to notice what happened. At this point, if we have this expression, we now default to, oh, what angle of cosine, or what angle gives me a cosine that's equal to root 3 over 2? Like, that's how we would interpret this statement. But we can make that question right here without ever doing that middle work. We can skip that thought and just jump right to it. If you want to use this, do it. I'm cool with it. It will work. If you want to use this, do it. I'm cool with it. It will work. The choice is yours. What the choice is not yours about, though, is what additional problems you get over the weekend. And it turns out, I'll go back down. I'm sorry, whoever didn't finish that. I want you to add the following. And you can just write them on there. I'm going to write add, and I'll put it all together online. I want you to add problems 2 and 3 and 7 and 10. And I know there's like sporadic, but it's better than me just saying like 1 through 55 odd, I promise. I want 13 through 15. I want 25 and 29. Ooh, I kind of like this one that has a fancy symbol next to it. Are you sure? 39. And I'm pretty sure I do. 98. Cool. Over the weekend, I don't want you to spend any more time than an hour. I want you to go to the games tonight. I want you to have fun. I want you to go to the games tomorrow. I want you to have fun. I want you to go to the dance tomorrow. I want you to have fun. I want you to come to chess club today from 3 to 5 and have fun. Cool. Remember, don't add or subtract to the population. We'll see you cool cats on Monday.